Hello, hello. Alright guys. Good day to you. How's it going? I trust you're all doing well. If not, I'm sorry to hear that. This video will be a tutorial video for section 8-1 ratios and proportions. There's going to be a lot of algebra involved. Okay, so let's start with number 2. So I'm doing the even number questions only because if you have a book, you can use that as a resource to answer the odd numbered questions. So let's look at number 2 here. Models. The Leaning Tower of Pisa in Italy is about 185 feet tall, so it's 185 feet. Let me zoom this in here a little bit. Closer image. And focus. There we go. So it's 185 feet tall. A model of the tower is, it's only 6 inches tall. What is the ratio of the height of the model to the height of the tower? Okay, so notice how the actual tower is 185 feet and the model is 6 inches, so we're going to need to convert either one of these. To avoid decimals, I'll convert the, well, no. So you can play around with this, but 6 inches is half a foot. So I can say 185 feet. Let's just say 0.5. So 0.5 to 185. It's useful to put this in terms of 1, like with the map. So to convert this to 1, I'm just going to multiply everything by 2. So multiply the 0.5 by 2 and the 185 by 2. So that'd be 370. Okay, and there you have it. So it's a 1 to 370 ratio. So just to recap what I did, I converted this 6 inches into feet. So 6 inches is half a foot. So I said, well, this is the model, and this is the actual tower. So the ratio is 0.5 to 185. These are in feet now. And then I multiplied both by 2. So I got 1. So the model is, if I had a 1 foot model, I'd have a 370 foot tower. Okay, so in other words, the tower is 370 feet, is 370 times bigger than the model. Okay, algebra. Okay, so these are all sort of the same here. If a over b is equal to 3 over 4, complete each statement. Let's just do all these. How's that sound? 4a equals blank. So it looks like they cross multiplied. So I got 4a equals, so they multiplied the a by the 4 and the b by the 3. So 4a equals 3b. This is cross multiplying. That's what we did there. Okay. Number 4, b over a is equal to, so this one they flipped it upside down. If a over b is equal to 3 over 4, then b over a is equal to 4 over 3. This one's flipped upside down. Next one, number 5. A over 3 is equal to, okay, so a over 3, I can see here a goes to the 3, then that must mean that b goes to the 4. So a over 3 equals b over 4. Just trying to see how we could have gotten this. Look at this one. This equation here was 4a equals 3b. We got that from cross multiplying. I'm going to try and get to this equation from here. So what I'll do is I'll divide both sides by 3 first. Now the 3's cancel, and then I'll divide both sides. So I'm at 4a over 3 equals b. Now I'll divide both sides by 4. When you divide by 4 and you already have something down there, it gets multiplied. Then the 4's cancel, and you get a over 3 is equal to b over 4. So I just confirmed that. Next one, number 6, I have 4 over 3 is equal to blank over blank. 4 over 3, so here's the original again. 4 over 3 looks like this, flipped upside down. So 4 over 3 is going to be equal to b over a, which is the same statement as this one up here. It's just written with the left side on the right and the right side on the left. So it's still a true statement. It doesn't matter which side you put it on the equal sign. Next one we have 4 over b. 4 over b is equal to, so they did the 4 over the b. I'm going to say it's equal to the 3 over the a. Let's see if I have something similar to this. Look at number 5. I have a over 3 is equal to b over 4. Okay, so can you all see how this is just number 5 flipped upside down, and then the left is written on the right side? So I'm going to write number 5. I'm going to bring it over here. I'm going to rewrite it so that the sides are flipped. So a over 3 was on the left, now it's on the right. Now I'm just going to flip everything upside down, which is still a true statement. Okay, so I'm going to write it upside down. And you have 4 over b is equal to 3 over a. Very good. Next one, number 8. It says 3b is equal to something. 3b is equal to 4a. Okay, that was from the cross multiplying. Number 9, a plus b over b. A plus b over b. So this is the one where they're adding 1 in essence. So b over b is in essence just 1. So a plus b over b is equal to 3 plus 4 over 4. Just like that. Okay, and this is still a true statement. Okay. Number 10, a over a plus b. So notice now the plus is on the bottom, we're adding b to the base. So if I've added b to the base, then I'm going to add the base to itself. So this would be 3 over 4 plus 4. Okay. Well, I apologize about that. That is incorrect. A over a plus b. So notice a over a plus b is really just a plus b over b, but upside down. So an equivalent statement to this would be that 4 is equal to, or sorry, a over a plus b is equal to 4 over 3 plus 4. Okay, so I just took this one over here and I flipped that upside down. Again, we're just talking about equivalent statements here. Last one, a plus 3 over 3 is equal to something. Okay, so where are we looking? A plus 3 over 3. Okay. I've added 1. I'm going to take this one here, this statement. A over 3 is equal to b over 4. I'm borrowing that from number 5. So a over 3 is equal to b over 4. Notice how they've added 3 over 3. I can split this fraction into a over 3 plus 3 over 3. So I'm really just adding 1 to this mix. And then I've gone and simplified it down here to one denominator. So if I were to do that to the right side, I would say b plus 4 over 4. Why? Because this here is b over 4 plus 4 over 4. So I'm adding 1 to both sides. So these are equivalent statements. Okay, let's move on. Algebra, solve each proportion. These should be quite a bit simpler because we're really just going to use one technique for all of these. I said do the odds, so let's go ahead and do the odds. Number 13, 9 over 5 is equal to 3 over x. I'm going to solve for x, so I'm going to cross multiply. So I get 9x equals 15. And then I will divide by, I'll divide by 9. X equals 15 over 9. Don't use a calculator here, use fractions. I can take a 3 out of each of these. X equals 5 over 3. Okay, if you use the calculator, it's 1.6. Number 15. 5 over x equals 8 over 11. We're solving for x. Okay, pause the video if you think you want to try this. I'm going to cross multiply. 55 equals 8x. And then I will divide by 8 on each side. So I get x equals, this would be 6 7/8. Alright. So notice I did that up here. Sometimes we flip the side. So like right here, I did a over 3, I put it on the right side, and I put the b over 4 on the left side. I did the same thing here. I just said that 55 equals 8x, and then I did the division and I put the x on the left side and the number on the right. That's totally fine. It doesn't matter what side of the equal sign it's on, because all an equal sign means is that it's equivalent to something. So equivalence works, it must work both ways. Okay. I'm not sure if we studied if and only if. An if and only if statement is only true if and only if something is equal to something else, meaning basically that it's equal going one way as it's equal going the other way, just like an equal sign. Alright, number 17 is the next one. Cross multiplying again, 5x equals 36. 5 by 5. I'm going to apply the equality principle here. So this will be 7 1/5 equals x. Notice I'm not really breaking this down because I can't. I'm just turning it into mixed numbers. 5 does not go into that one nicely. Number 19, x plus 7 over 7 equals 15 over 5. Okay, two ways I can do this. The first, I'll just simply cross multiply. 7 times 15 is 105. Okay, I can distribute first, or I can just divide by 5. So I'll go ahead and do that. There's actually a lot of ways to do this one. So I get x plus 7 equals, that'll be 21. Minus 7 from each side. X equals 14. That's one way to do it. Another way is to reduce this right off the bat. So now I cross multiply, you get x plus 7 equals 21. Subtract 7, you get x equals 14. That's a lot easier. It deals with smaller numbers. So try to simplify things first. 21, geography. The scale for this map of Louisiana is 1 inch is equal to 40 miles. On the map, the distance from Lake Charles to Baton Rouge is about 3 1/8 inch, about how far apart are the two cities. Okay, so our ratio is 1 inch is equal to 40 miles. Okay, if something is 3 1/8 inch apart, so 3 1/8 inch apart, what do you think I have to do to the 40? So I took this 1, I multiplied it by 3 1/8 inch to get 3 1/8 inch. So I'm going to need to multiply the 40 by 3 1/8 inch. I'm going to turn it into an improper fraction first, because I like improper fractions. So 25 over 8 inches is equal to 40 times 25 over 8. I can take out 8s out of this. So the two cities are going to be 5 times 25, which is 125 miles apart. Map reading. Measure the distance, then find the actual distance. Okay, let's look at number 23. So you're supposed to use a ruler for these. We're doing Vinton to New Roads. I don't have a ruler on me, so I'm just going to approximate. I have no idea where New Roads is. Or Vinton, I don't see either. Oh, there's New Roads right there. And then Vinton. Vinton, where you at? Oh, there's Slaughter. Port Vincent. Bear with me, guys. Oh, wait, it's way down there. Okay. So we want to measure the distance to each. Okay, so we're just doing straight up distance. We're not worried about how far it is on a highway. If we wanted to do that, we'd have to actually go by the roads. You'd have to go New Roads to this highway, and then to Livonia, and then to Plaquemine, and then to Vinton. We're not doing that, so we're just going to do a like a bird's distance. What do they call that? Bird line of sight. 1, 2, 3. So it's about 3 inches. Okay, so we're looking at 3 inches. So if 1 inch is equal to 40 miles, then 3 is going to be equal to 40 times 3, so that's 120 miles. So that distance there is about 120 miles. Alright, and last one I'll do here with you guys, number 25. Design. You want to make a scale drawing of your bedroom to help you arrange your furniture. You decide on a scale of 3 inches is equal to 2 feet. Your bedroom is a 12 by 15 rectangle. What should its dimensions be in your drawing? Okay, so let's draw this one out here. Your bedroom is 12 by 15. Those are feet. And 3 inches is equal to 2 feet. You want to know how big your scale drawing should be. So the rectangle here is 12 feet. Every 2 of these, so I'm going to split this into 2-foot sections. So I got 1, 2, 3, 4, 5, 6. Each of these is 2 feet. 2, 2, 2, 2, 2, 2. Each one of these is going to be 3 inches according to your scale. So that'd be 3, 3, 3, 3, 3, 3. That's 6 by 3, so that's 18 inches will be your height. And then the length here, so it's 15. 2 doesn't go into 15, but it goes into 14 7 times, so 7.5 times. So I have 7.5 2-foot segments. on the base there. So each one of these in my scale will be 3 inches, so I'm just going to multiply 7.5 by 3. So you should get, what, 3 by 7 is 21, 3 by a half is 1.5, so 22.5. So your length is going to be 22.5 inches. And check to see if this is right. We're looking at a 5 to 4 ratio of length to height, so this should also be 5 to 4, which is true, right? Because this is 18 is 4.5 divided by 4, 22.5 is 4.5 divided by 5. So this is still a 5 to 4 ratio. So we are correct in doing our math there. So to recap, we split this into segments. Here I had 6 2-foot segments, and then for this bottom one I had 1, 2, 3, 4, 5, 6, 7 and a half 2-foot segments, and then each one of these is 3 feet. This is 3, 3, 3, 3, 3, 3, 3, and since this is a half, that's a 1.5. So it'd be 3 plus 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 1.5, and that'll get you 22.5. Very useful skill for carpentry or for any sort of trades. If you are interested in that sort of thing, there's a lot of algebra out there, and you thought this was a useless subject. Alright guys, happy math. Let me know if you have any questions with anything. Take care.